wabarakatuh. We are from group Gottfried, Calculus 1. My name is Muhammad AryaPutranegara from Industrial Engineering.
My name is Ahmad, Vito, Ardiansyah, Nursdin from Arsitektur.
My name is Damar Widyargo from Civil Engineering.
My name is Januar from Civil Engineering.
My name is Imam Dhaifullah from Civil Engineering.
So in this video, we will explain about limit theorem and limit trigonometric. Hope you enjoy the video.
So today I want to explain about the theorem limits. So there are several forms for the theorem limit itself. From myself, I want to explain about 6 kind of form, and this is the first form of the theorem limits. So the first one is limit x approaching a k equals to k, with k is real element numbers. And then for the second form or second type is limit x approaching a c time function of x is equal to or you can change it into c times limit x approaching a function of x. So the next one is the third form of the theorem limits. So the third form or third type is limit x approaching a fx plus minus gx is equal to. So in here you can separate the limits of function of fx and the function of gx, and so the form it's gonna be like limit x approaching a fx plus minus limit x approaching a function of gx. We move into the next one. It's limit x approaching a fx times gx is equal to. So in here it's kind of same from the previous type. So you can separate the limit of fx and limit of gx. So the form will be like limit x approaching a fx times limit x approaching a gx. So the next form or the next type of the theorem limit is the fourth form. The fourth form is the limit x approaching a fx divided by gx. So it's kind of same like the previous type or previous form. You can separate between the function of fx and the function of gx. So it's gonna be like limit x approaching a fx divided by limit x approaching a gx. So the last form or the last type that I want to share to you guys is the limit x approaching a function of fx to the power of n. It's equal to limit x approaching a function of fx to the power of n. So you can move the exponent from the inside to the outside.
Function example lim to x plus 3 equals x to 3. Then we just enter 2 into x in the given function lim. That means 2.3 plus 3 equal 6 plus 3, 9 x to 3. So this is just the basic one. So we will test with several values that are closest to x in the question. In the question just now it says x to 3. So we will take at least 2 numbers before and after 3, but try not to be far apart. For example, for number before 3 it's 2.90 and 2.99, while the number after 3 are 3.1 and 3.01. So if you make it on a number line, it looks like this: 2.90, 2.99, 3.1, 3.01, and 3.1. Then test each number into the function. it means 2x plus 3 for 4x to 90 2.90. Then it becomes 2.290 plus 3 equals 8. So it just goes the same with 2.99, 3.01, and 3.1. So we just gonna make it quick right here. Sorry. So if this right here is 2.299 plus 3, meaning that 8,098. Okay, sorry. For 3.1, then it becomes 3.01 plus 3 equals 902. For the 3.1, just place it like this. 2.3 plus 3 equals 9.20. So this is just the example of the hard way. Well, it can be seen that the closer you get to x equals 3, right here, the closer result is to 9, then it can be concluded that the result of the limit problem is limit to x plus 3 equals 9. So this is the same to this one. So if you want to take it the simple way, you can take it. But if you want to calculate all before and after, this is this. Thank you very much.
Trigonometric function limits are the values reached by a trigonometric function when the variable approaches a certain value. There are several benefits of using trigonometry limits. Trigonometry limits are often used to determine the integral limits of a function. By using limits, we can determine the integral value of a function more accurately. Trigonometric limits can also be used to solve differential equations, which are mathematical equations that explains how a function changes with time or other variables. By using limits, we can understand the properties of a trigonometric function, such as whether the function is limited or not, and whether the functions change at certain values or not.
Trigonometric limit. Determine the limit of lim x towards 0 sin 2x per sin x. So if we substitute x into 0, sin 2 0 per sin 0 equals 0 per 0, and it is wrong. So the solution is lim x toward 0 sin 2x per sin x. We can use the characteristic of limit, and then we turn sin 2x into 2 sin x cos x per sin x, and then we can eliminate the sin x, and then we get lim x toward 0 2 times cos x, and then we can substitute x into 0. So 2 times cos 0, and because cos 0 is 1, so we get 2 times 1, and the answer is 2. And that is the solution of determine the limit of lim x toward 0 sin 2x per sin x.
Next is the application of limits in life. The concept of limits is widely applied in our lives. For example, in the field of architecture, architects use limits as a means of applying analytical skills to provide a reasonable estimate of risk levels and mathematical models. In the field of medicines, limits are used to measure a patient's nearsightedness or farsightedness.
That's all from us. Thank you for watching. Hope this video educates you guys all. And we are sorry if there are any wrong words. Thank you.
Thanks for watching.